All right, folks, yesterday we started reviewing the laws of exponents, and we're going to continue with that today. Now, the first thing we did is we reviewed just a little bit of basic information about exponents. So we know if we have something like x to the 5th power, okay, we talked about the fact that that x is called the base in that expression, and that the 5 then is the exponent. So this x is our base, and that 5 is the exponent. And we also reviewed that exponents are actually repeated multiplication. So it's a short way to write repeated multiplication. The base is what you're going to repeat, and the 5 tells you how many times to repeat it. So in this multiplication problem that's represented by this expression, there are 5 x's, and those 5 x's are being multiplied together. So the base is the repeated part of the multiplication problem, and the exponent tells you how many times that you're going to repeat it. Now, at this point, we have talked about 2 laws for exponents. The first one was the product rule. And the product rule tells us how to do multiplication problems that involve exponents. It says that if you have a base raised to a power times the same base raised to another power, so x to the a times x to the b, that you keep the base and you add the 2 exponents together. So that would be x to the a plus b. Remember, though, that the product rule does rely on those 2 bases being the same. And then we also talked about the power to a power rule. Now, in that one, you will have a base raised to a power, and that will be wrapped in parentheses and then raised to another power. So in this case, I have x to the a power, and then all of that is being raised to the b power. And what that rule told you to do in that situation was to keep the base and then multiply the 2 exponents together. So the product rule is for multiplication problems. It tells us that we can add exponents when the bases are the same. And the power to a power rule tells us what to do when we're raising a power to another power. And in that case, we multiply those exponents together. And what we're going to do today is add on 3 more exponent rules. So here we go. All right. The third rule for exponents, the third law of exponents that we're going to talk about is called the quotient rule. And you all will remember that the word quotient, it means the answer to a division problem. So this quotient rule is going to talk to us about what to do with exponents when we are doing division problems. So if you have a base x raised to a power a, and you're dividing that by the same base x raised to another power b, what the quotient rule says you can do is since those bases match, you keep the base and you subtract the exponents. So you would do a minus b. So to put this in real terms, the quotient rule tells me that if I wanted to do x to the 10th power divided by x to the 4th power, that I could do x to the 10 minus 4 power to get my answer. So that would actually be x to the 6th. And if you think about it, that makes a tremendous amount of sense. Because yesterday, when we were doing multiplication problems, we added our exponents. So now that we're doing division problems, we're going to do the opposite. We're going to subtract our exponents. let me again, just to be on the safe side, show you why this works. And let me do that with a problem that's a little simpler. Let me do this with x to the 5th power divided by x to the 3rd power. According to this quotient rule, I should be able to subtract my exponents and get x squared as my answer for that. 5 minus 3 would give me a 2. Now, to show you why that works, think about x to the 5th power. We're going to take the base x and repeat it in a multiplication problem 5 times. So 1, 2, 3, 4, 5. Now I'm dividing that by x to the 3rd power, which means I'm going to take the base of x and repeat it 3 times in a multiplication problem. So 1, 2, 3. Now, here's what's going on here. Right here, what I have is x divided by x. That's the same thing as saying that I'm taking a number and I'm dividing it by itself. Now you all know what happens when we do that. When you take a number like x and you divide it by itself, what happens is you get 1 as the answer. So that x divided by x that I have right there is going to turn into a 1. Right next door, I see that again. I see an x divided by an x. That's going to turn into a 1. And then finally, one more time, I see an x divided by x. That's going to turn into a 1. So 1 times 1 times 1 would be 1, of course. And I want you to notice that at that point, I can't do any more of that dividing because this x doesn't have 1 on the bottom to divide by. Neither does this guy. So right here, this leftover part is my answer. And I have x times x, which is the same thing as x squared. X squared. So that should show you why that quotient rule works. So the quotient rule tells us that when we are doing a division problem, that we are going to subtract exponents. So I want you to notice that figuring out how to do these problems is going to hinge on recognizing what kind of problem it is. Am I doing a multiplication problem? Am I doing a power to a power problem? Am I doing a division problem? That's going to help you to decide what to do with these exponents. So let's do some quick examples for the quotient rule. If I'm doing x to the 12th power divided by x to the 4th power, my bases match, so I can use my quotient rule. I'm going to keep the base and subtract the exponents. 12 minus 4 is 8, so I would get x to the 8th power for that. And again, what you're going to see here is that they can put as many bases in these problems as they want. So if I had a to the 4th, b to the 5th, divided by a, b to the 3rd, because this is a division problem, I can still use my quotient rule. But what I'm going to have to do is use the quotient rule for the a's, and then also use the quotient rule for the b's. So I'm going to have to repeat that quotient rule for each of the bases. So for the a's, I would subtract my exponents and do 4 minus 1, which would make that a to the 3rd. And then for the b's, I would do 5 minus 3, which would give me b to the 2nd. So it doesn't matter how many bases they stack up in the problem, do the quotient rule for each different base. And then, of course, when we talked about these exponent rules yesterday, we also talked about coefficients. So those are those big numbers that sit out in front. And what I want you to remember is that we don't use the exponent rules on those. So if I'm doing 10x to the 7th y to the 4th divided by negative 2x to the 3rd y to the 2nd, when I go to those coefficients, I'm going to do what the problem says to do. And I can see here that this problem tells me that I need to take the 10 and divide it by the negative 2. I need to divide those because this is a division problem. So 10 divided by negative 2 would be negative 5. And now I'll use my quotient rule with these powers and subtract my exponents. So x, I'll do 7 minus 3 to get x to the 4th. And then y, I'll do 4 minus 2, which will give me y squared. So I'll get negative 5 x to the fourth, y to the second as that answer. So when you're doing division problems, subtract the exponents that are on the same base. If you see coefficients, divide them, since it's a division problem. So that's how the quotient rule operates. Now, these next two rules, I'm just going to tell you right up front, they're important. But you always want to save these two rules for the end of any problem that you're doing. Okay? So our fourth exponent rule that we'll talk about is the zero exponent rule. And what the zero exponent rule tells us is that if we take any base and we raise it to the 0 power, that the answer will always be the same, and that answer will be 1. So the zero exponent rule just basically tells you that if you take any base that you want and raise it to the 0 power, that the result will always be 1. Now let me tell you this, there's only one base that doesn't work for. That doesn't work for 0. So that x in that 0, this x in this zero exponent rule cannot be 0. It doesn't apply for that. So that is the one exception to that rule. And you know, if you want to try this on your calculator, try doing 2 raised to the 0 power and 27 to the 0 power, and what you'll see is the answer does indeed always come out to be 1. And then finally, the last rule that we'll talk about is the negative exponent rule. The negative exponent rule. And here's what it tells you. It tells you if you have a base raised to a negative power. So if I have x raised to the negative n power, that will be the same as 1 divided by x raised to the positive n power. So if I have x raised to the negative n power, I'm going to rewrite that as 1 divided by x raised to the positive n power. So here's what this is really saying. If you have a base raised to a negative power, you are going to move that to the bottom of your answer. You're going to move it below the fraction bar, and that exponent will become a positive. So real quickly here, if I had x to the negative 3 power, that would be the same thing as 1 divided by x to the positive 3 power. If I had x to the negative 8 power, that would be the same as 1 divided by x to the positive 8 power. And I'll show you a little more about how to use that in some problems that we have coming up. The big thing I want you to understand about these two rules is that in algebra, your final answers need to be written using only positive exponents. So zero exponents and negative exponents are not allowed. Not allowed in your final answers. And I'll show you a little more about that in just a minute. So, you have now all 5 of the rules for exponents. And so now what we want to do is look at some problems that are multi-step problems. So what that means is they may not be as short and sweet as a lot of the examples that we've looked at so far. You may have to use more than one of these exponent laws to get your answers. Now, let me give you this little helpful hint. When you're doing exponent problems, if I were you, I would always look for that power to a power first. So that would always be my first thing that I'm on the lookout for. And remember, power to a power will recognize because you will have a base being raised to a power, wrapped in parentheses and raised to another power. So that's how I'll recognize that. Now, after you look for that, the next thing I would look for is my product and quotient rules. And if they're there, I would do those next. So look for multiplying or dividing being done in the problem. And then I would finish my problem off by then taking care of my zero and negative exponents and making sure that those have been taken care of, that my answer, my final answer, has only positive exponents. So let me start here by showing you what I mean. So this is the first problem we'll do. Let's do 3x to the negative 4th power, y to the 9th power, times 8x to the negative 1 power, y to the negative 6 power. All right, so when I look at this problem, do I see power to a power? Do I see a base raised to a power, wrapped in parentheses, and then raised to another power? And the answer is no. I don't see anywhere up here where I'm taking a power and then raising that to another power. So I'll move on to this next level. I'll look for products or quotients. And here I definitely see a chance to use my product rule because this is a multiplication problem. And product rule tells me what to do in a multiplication problem. So here's what I would do first. Take care of your coefficients. So you're going to do 3 times 8. And that will give you 24. And now the product rule takes over and tells you that when you're multiplying powers that have the same base, you add the exponents. So we're going to have to do the product rule for x and then the product rule for y. So for x, we will add negative 4 plus negative 1, which is negative 5. And then for y, we'll add 9 plus negative 6, which is 3. Now let me say something here real quickly. When you are doing exponent rule problems, you want to make sure in your final answer that you only have one coefficient and that you only see each base one time. So when I look at what I have here right now, I see that I only have one coefficient now where I had 2. And I only see the base of x one time and I only see the base of y one time. When I get to that point where I only see one coefficient and I only see each base one time, that's a pretty good indicator that I'm pretty close to being done. Now, the last thing to do then is to look at this answer and see if I have any zero exponents or any negative exponents that need to be taken care of. You'll notice there are no zero exponents up here, but we do have a negative exponent in this problem. We do have negative 5. Now what's going to happen is that x being raised to the negative 5 power is going to cause that to drop to the bottom of the answer. So this answer is going to have a fraction bar in it. Now the 24 and the y to the 3rd are both going to be on top of that fraction. And the reason they're going to be on the top is because neither of those are being raised to a negative power. Only things that have a negative power will drop into the bottom of your final answer. So this x to the negative 5 power is going to drop into the bottom, and when it drops, it loses that negative. So when x to the negative 5 goes to the bottom, it's going to change to x to the positive 5 power. So to kind of emphasize this again, negative exponents at the end are going to drop to the bottom of the answer. So there will be a fraction bar. Anything that isn't raised to a negative power will stay up top, and anything with a negative exponent will drop down to the bottom. And when they do, they lose that negative. So we get 24y to the 3rd over x to the 5th for that answer. Okay, let's try another one. All right, so in this problem we are doing 2x to the negative 2y to the third, all being raised to the fourth power, times 2x to the 19th y to the negative 6th. So the first thing I want you to do, remember, is to look for power to a power rule. And this problem has it, because everything that is inside this set of parentheses is being raised to the fourth power. So right here is the first part of the problem that I'm going to have to deal with. I'm going to have to do this power to a power part of the problem. So the first question for me is, what do I do with this coefficient? Well, everything in these parentheses is supposed to be raised to the fourth power. So I need to do 2 raised to the fourth power, which would mean 2 times 2 times 2 times 2. That will give me 16. And then the power to a power rule tells me that I multiply exponents. So I'm going to have to do that for x and for y. So for x, I'll do negative 2 times 4, which is negative 8. And then for y, I'll do 3 times 4, which is 12. So I raised my coefficient to the power, and then I used that power to a power rule to multiply my exponents. And I'll just transfer this down now. Now, after power to a power, I want you to look for products or quotients. And in this case, we have a product. We are multiplying. So we're going to use our product rule. First, let's deal with coefficients. We are going to multiply the coefficients. So 16 times 2 is 32. And then our product rule tells us to add exponents. So we're going to do that for x first. Negative 8 plus 19 is 11. And then we're going to do that for y. 12 plus negative 6 is 6. And now we'll take a look at this answer and we'll check it for zeros or negatives. Now, by the way, I know that I'm close to being done because I only see one coefficient now, and I only see one x and one y. So that's what we want, is to only see one coefficient and one of each base. So I know I'm pretty close to being done now. Any zero exponents? No. Any negative exponents? No. So what that means is this is the final answer. So we are using all of these different exponent rules to do these problems, but we're doing one thing at a time. We're taking one thing at a time. All right, so on this problem, do I see power to a power rule being used? And the answer is yes, I do, because I see these parentheses and everything inside is supposed to get squared. So this is what power to a power rule is designed to help me do. So I'm going to do this part of the problem first. Start with your coefficient. You're going to do negative 5 squared. Negative 5 raised to the second power. You know that means negative 5 times negative 5, so that's going to be 25. And then for each of these bases, for x and for y, you'll use that power to a power rule to multiply your exponents. So for x, we'll do 6 times 2, which is 12. And then for y, we'll do 2 times 2, which is 4. And we'll bring down the rest of this problem. Okay, so now look at the problem. We've taken care of power to a power. Do we see any products or quotients? We see a product. So for this problem, the next thing we are going to do is we are going to use our product rule to multiply. So let's start with our coefficients. We have 25 and 12. And we are supposed to multiply those coefficients. So 25 times 12 would give us 300 as our new coefficient. And then in a multiplication problem, our product rule tells us to add exponents. So for x, we're going to add 12 plus 2, which is 14. And for the y's, we're going to add 4 plus negative 4, which is 0. So notice, I see one coefficient, one x, one y. I'm in good shape here. So now we think about zeros and negatives, any zero or negative exponents, and we see one this time. Y is being raised to the 0 power, and what we know is that turns into a 1. Any base being raised to the 0 power turns into a 1. So you have 300x to the 14th times 1. And you all know what happens when you multiply something by 1. It stays the same. So this final answer on this one will just be 300x to the 14th. All right, take a look at this one. So on this one, when I'm looking at it, I want to start out by looking for power to a power. And I see that I have that here in the bottom. Everything inside of this set of parentheses is supposed to get raised to the second power. So I'm going to do that part of the problem first. So I have 36 x to the 10th, y to the 9th. And it's going to be divided by the answer that I get from this bottom part of the problem. So I'm going to take my coefficient of 2, raise it to the second power. That's going to give me 4. And then power to a power tells me to multiply exponents. So for x, I'm going to do 8 times 2. And for y, I'm going to do 6 times 2. So take care of that power to a power first. Now, quotient rule. I see a division problem in front of me, so now I'm going to do quotient rule. Divide your coefficients. 36 divided by 4 is 9. And now we subtract exponents. So for x, we're going to do 10 minus 16. That is a negative 6. For y, we're going to do 9 minus 12, which is a negative 3. And now notice we have one coefficient, one x, one y. So that's a good sign, remember. But notice this time in our answer, we are seeing these negative exponents. And when I see negative exponents, I know that means my answer is going to end up having a fraction in it. Now, what's being raised to a negative power? Well, the x is. So the x is going to need to drop down to the bottom of this answer. And the y is. He's going to need to drop down to the bottom. That 9 is the only thing that is not being raised to a negative power. So you're going to leave the 9 on top of this answer. And you're going to put x to the positive 6 on the bottom and y to the positive 3 on the bottom. So those negative exponents drop to the bottom and lose their negative. Drop to the bottom and lose their negative. So this would be my final answer. Okay, I want to look at one last problem with you. And then I'm going to let you practice for a bit with this. Okay, so here is the last example we'll take a look at today. So in this problem, hang on, let me clean up just a little bit here. I notice I've got a little stray mark right there. I don't want that to be confusing. That should be a times symbol right there as well, so let me make that a little better. In this problem, Do we see anywhere where we're raising a power to a power? And the answer is yes. Here we see that everything inside parentheses is being raised to the second power. So we're going to take care of that first. So our coefficient -8 is going to get squared. That'll give us a positive 64. And then we will use that power to a power rule and multiply our exponents. So x will be to the 3 times 2 power, and y will be to the 2 times 2 power. The rest of this problem will just move down. Now, after we look at power to a power, then I want you looking for products and quotients. And you'll notice in this problem that we have both. There is a product rule because we are doing multiplication, and there is a quotient rule because we are doing division. Now what I want you to notice is it would be better to go ahead and do this product on the top and get that squared away. Get the top finished before we try to do the division. So I'm going to use product rule on what I just highlighted in blue. So I'm going to multiply my coefficients. 64 times 2 is 128. I'm going to add my exponent, so x will be to the 6 plus 2 power, and y will be to the 4 plus 6 power. And then the rest of that problem will just move down. All right, one last thing to do. And you know, one of the things I want to kind of stress again here is I know I'm not finished with this problem right now because I'm seeing 2 coefficients. I'm seeing the x variable twice, and I'm seeing the y variable twice. So that lets me know, hey, you're not done yet. So let's do this division problem that we see in front of us. First, we're going to divide coefficients. 128 divided by 32 is 4. And then we subtract exponents. So for x, 8 minus 8 gives us x to the 0. And for y, 10 minus 3 gives us 7. So now I'm feeling a little better about this because I see one coefficient, one x, one y. Any zeros or negatives? Well, yeah. We've got this x to the 0 power here. We know that's going to turn into the number 1. So 4 times 1 makes that 4, y to the 7th. So notice if any of those variables are raised to the 0 power, what actually ends up happening is they just disappear from the problem. So you have all 5 rules now. And I want you to try the problems that are assigned for today. For those of you who are virtual, if you're having any trouble at all with this, then shoot me an email and let me know you're having trouble so we can set up a Zoom meeting for next week and get you some help on it. For those of you who are hybrid A students, I will see you in class on Monday and Tuesday. So if you're struggling at all with this, come prepared on Monday with your questions, and we will take care of those. I do want to remind all of you who are listening to this video that the 9 weeks ends a week from Monday. So it ends on October 26th. So this is a good time to look at your progress report if you were in class to get that, or check the student portal if you are virtual, and make sure that your grade is up to date and taken care of, and to get any of those last minute assignments turned in. But like I said, if you do have questions on this, certainly let me know.